Good evening, everybody. So the Midnite One inverter is a 10 kilowatt inverter with an 11.4 kilowatt output when solar comes in. But what if you need more than, 10,000 watts after the sun goes down? Well, you get a second one. And so tonight I want to go through and take a look at what does it take to parallel or stack these two inverters for a combined total output of 20 kilowatts or just shy of 23 kilowatts when PV's coming in. So let's find out together. So I went through all the specs in a previous video, which I'll link to here. But if we put both of these together, that gives us the ability for, like I said, 20 kilowatts of output straight from the batteries, almost 23 kilowatts when you include PV. Each inverter can handle up to 15 kilowatts of PV on their own. So that gives you a combined total PV input of 30 kilowatts across 6 MPPT trackers. Plus, you could handle up to 10 kilowatts of AC coupled PV per inverter, giving you an additional total of 20 kilowatts of PV input. So I've got on the table a lot of the different components that we're going to need in order to parallel these two inverters. The manual does a very good job of explaining what needs to be done, and there's really not a lot. You've got your AC connections, you've got your battery connections, you've got a paralleling cable, and then you program the parallel connection. I mean, that's really about it. So I've got our cables already cut to length for the AC connections. We've got a cat cable over here for our parallel cable. We'll use a torque screwdriver, some gloves, a pair of pliers, a flat blade screwdriver. So first thing, we can see that both inverters are turned off. We don't have any lights up here. If I press the buttons on the side, the displays don't light up. But just for peace of mind, we're going to check the AC connections to make sure that there's no power there. So I've got all the breakers turned off. This is my initial inverter. This is going to be the master inverter. So we'll check for output. No output. Check for input. No input. On the new inverter, we don't have anything connected, but I'm still going to check. No output. And obviously, no input because there's nothing there. Breakers are turned off. In the new inverter, we do have the battery connections already there, but I do have my ground connection already in. And if we open up the wireway, we can see per the manual spec, we've got the ground line. That's going to my grounding terminal in my wireway, and we've got the toroid wrapped twice around that line. But everything else still has to be hooked up. Your cabling does need to be the same length to make sure that everything is shared equally between the two inverters. So my battery cable length was measured. It's all the same length. That's why there's so much extra going to this inverter right now. So my plan is to go in order with those few different pieces and just break this down in different sections of how to hook this up. And if you've seen any of my previous videos, they all have one thing in common. They're typically longer videos. And that's kind of because I like diving into the details of things. So like all my other videos, I will have chapters so that you can quickly jump around to the different parts that you need to follow along with. So let's get into that first piece, which happens to be the biggest one, which is the AC connections. So from the AC side, you kind of have to look at two different aspects. You have to look at the input and the output. So we're going to look at the output first because that's what everybody's going to be dealing with. Some people might not have any AC input coming into the inverter, so we're going to look at output first. But there's going to be similarities between wiring up the input and the output. So since these are 240 volt split phase inverters, you have to look at combining both legs from each inverter into one place to utilize the output from both inverters. So I ended up ordering some, I think it's Merson PDBs off of eBay. They're like $45, maybe 43, 45 bucks. They're 1,000 volt rated. I believe the ones I got were rated up to 175 amps. So I got 2 sets. Each one has 3 terminals, so I can use it from each leg plus the neutral. So the top one is for my AC input, the bottom one is for my AC output, and you can see kind of on the back wall, I actually wrote in and out so that I can remember which one is which. So if I open the covers, so there's 4 terminal points on the left side and 1 on the right hand side. We can put from 4 gauge to 14 gauge on this side, and we can have from 2/0 to 14 gauge on this side. And this way I only have to deal with my connections here, and I only have to run 1 set of cables up that conduit to my combiner box. In my particular case right now, this is demonstration purposes only, these gauge wires over here are not sized properly. So do not follow this as a end-all be-all. These are still 4 gauge wire. My loads right now will not exceed 4 gauge wire, even with the 2 inverters. They'll be split between them, but they will not exceed the current rating of a 4 gauge wire. So I do need to upgrade these at some point so I can add more loads, but for the time being, I know somebody's going to say something about it. Yes, these are not larger gauge wires that 2 combined 4 gauge wires would be able to handle. And again, these aren't even 2 gauge, they are 4 gauge. But I know my loads right now, it is configured for my current loads. So with that disclaimer out of the way, I actually wired these so that the bottom terminal is always going to be the closest inverter. The top terminal will be the furthest away. So we will have L1 and L2 for the output of the second inverter. And then the same thing as well with the inputs, L1, L2, and neutral. And since it's a common neutral, I do have only a single neutral running over there as opposed to multiple neutrals. So then your output of that PDB, the combined output of both inverters, you would run 1 set of wires, L1, L2 neutral, and your ground, out of that block, and then you would take it to your critical loads panel. From the input standpoint, this is my grid breaker panel. I have 1 double pole breaker for my test wall. Those leads come from this panel, come over and down into that PDB for the AC input that we just saw. And so from there, I can then split and have it go to each inverter. So all my AC connections now are going to be down in here instead of having to run multiple lines to a critical loads panel. It drastically simplifies things. So let's get to the actual wiring. So we'll feed these lines up from underneath. I do already have both sides taped with the L2 red tape. And we'll slide them up into the output terminals. I'm going to use my VVOR torque wrench, which should already be programmed to the torque spec for these breakers, which is 35 inch-pounds. Hopefully that's actually showing up. So I'm going to hold the one in there and just torque it down. This was a great investment. If you don't have a torque screwdriver, I'll link down in the description below for this one. This one's great. You can program foot-pounds, inch-pounds, Newton meters, and it just beeps at you when it's tight. So now we've got our output torqued down over here. The one thing I don't like about all this is just the fact that it does get very messy with a lot of these wires in here. But there's really not much you can do about that, is there? So we've got our black line for output. The bottom PDB is my output. The top PDB is my input. So I'll run my leg 1 into, and remember this PDB is designed for 4 gauge is the largest that can go on this side. So it's very snug. So if you got 2 gauge, you would have to get a different size PDB. And then I just looked at a picture of the torque rating of these. And so thankfully, the load side of these PDBs, which the left side with multiple terminals is the load side. This is actually, they refer to this as the line side. The load side torque spec for a 4 gauge wire is 35 inch-pounds as well. So thankfully, I don't have to make any adjustments on my torque wrench. So there's my line 1. And line 2. And since we're already down here on this side, let's add the neutral. Leg 2. And leg 1, if you can see that. So we've got our connections in here, they're torqued down, so I'm just going to close the covers. Then they have a nice little access hole in the middle of the covers if you need to put a probe in there to check your voltages without having to expose the entire terminal. So that's a nice feature too. So now, no accidental touching. So let's feed our leg 1 and leg 2 lines up. And then lastly, we'll take our neutral line and feed our neutral up to the neutral lug. And these larger terminals look like they're, I think, 26 inch-pounds. I don't know if you can actually see that or not. 26. Very handy. So from the AC wiring standpoint, everything is wired up. We've got our leg 2 on the right, leg 1 on the left, and our neutral, and then our ground. Over here, leg 2 on the right, leg 1 on the left, our neutral, and then our ground. And then it all goes down to our power distribution blocks for our inputs and our outputs to combine everything there. From this standpoint, it's probably going to be fairly similar across almost any style inverter that you're looking to parallel. Now, because I'm looking at combining multiple power sources, I want to make sure that I have things wired correctly. So what I tend to do is I'll grab my meter, switch to continuity mode, and then when these 2 probes touch, they make a beep. So I know that they are completing a circuit. So let's see if that stays. And we're going to check and make sure that circuits are connected together. So L1 output, L1 output. L2 output, L2 output. L1 input, L1 input. L2 input, L2 input. Come down to our neutral bars. Good. Our ground bars. We've got things wired up properly. So we've got the hard part done. The AC wiring, we've got it combined for our output and our inputs into both of these inverters. So when they're both all turned on and configured properly, we should have 20,000 watts of output capability. So I'm trying to remember. Part 1 was our AC connections. I believe part 2 is our DC connections. And really that's just making sure that you've got your DC battery cables connected in to both inverters. And then whatever PV lines you want run to both inverters, you need to get connected in. You don't have to have PV in both, but you've got it. You might as well use it, right? At this point in time, I don't have any extra PV to add. So our DC is done, And I believe I mentioned this earlier, but you do want to make sure that your DC cables, your battery cables, are the same length so that it has equal power flow. So part 3 or step 3, whichever one I've been using, because I don't remember. We need to add a parallel communication cable between the two inverters so that they can talk back and forth and synchronize their settings and information. So I just grabbed a Cat 6 cable that I had laying around, cut it to length so it'll go down into the wire trough, and then I just ended up picking 4 colors that I wanted to use. So I picked the 4 solid colors in that wire. So I stripped the wires, cut off the extras, and exposed the ends for each one. These are going to end up going into a push pin style terminal block on each inverter. Now, I will warn you, it is going to be a little bit of a pain in the butt. And that's putting it nicely. The terminal block is, I'll just show you. So inside the inverter, directly beneath the AC input, so right here is where we're having to wire these in. So there is ports 1 through 4, and there's 2 sets of each. Now, the top set and the bottom set are bonded together, so you can use the top row or the bottom row. It doesn't really matter. You just have to use all 4 ports. So I'm going to feed my parallel wire up through the bottom. I have been told that they are going to make improvements on this in the future to where it can be a removable terminal block similar to the style that Victron has for their terminal blocks. And this is where I'm going to recommend you need a set of needle nose pliers and a small screwdriver that you can use to push in these orange terminal locks. And then I would also recommend you start from the right because it makes things easier. So grab your first wire with your needle nose pliers, and you have to get it up into the slot from underneath, and then use your screwdriver to push the orange push release up, push up with the needle nose pliers, and then release your screwdriver, and it should go in all the way. And then you repeat with the next wire. This is even harder when the camera's in the way. All right, not pretty. I'm sure you probably saw mostly knuckles and gloves in that. But I would recommend doing a tug test, just a gentle tug test on each wire to make sure that it's up in there. And you might say, if the top and the bottom row are bonded together, why did you use the bottom row? And I'll show you that in a minute. So let me get the other side done, and I'll show you why I use the bottom row. All right, so from the right on pin number 4, we've got green. Pin number 3 is brown. Pin number 2 is orange, and pin number 1 is blue. And we've got pin number 4 is green. Pin number 3 is brown. Pin number 2 is orange, and pin number 1 is blue on the second inverter. Now, you can use whatever color you want of those wires. You just have to make sure that pin 1 matches the same for each inverter, pin 2 matches the same for each inverter, and so on. I'm going to focus in on the first inverter, just because it's easier to see one than to try to squint and see both. But the reason that I used the bottom row on both is so that I can actually test and tone to make sure that I have matching pins on each inverter. So the same way that I tested for my AC input and AC output, I used continuity mode on my multimeter, and I take one of my probes and go up into the terminal block on pin 4. I come pin 4 on the other inverter, and you hear the beep. And then I move over to pin 3 and pin 3. Okay, we're good. Pin 2 and pin 2. Good. Pin 1 and pin 1. Good. But that's why I use the bottom row. If you're paralleling more than 2 inverters, then you're going to end up using the top and the bottom rows, and you'll have to refer to the manual for paralleling more than 2 inverters together. The other thing that we need to do on both inverters is this little switch right here needs to be slid up to the on position. So that needs to be up for both. It will be different if you do more than 2 inverters. I believe the first and the last will have this switch up. The one in the middle will have it switched down to the 1 position. But since we only have 2, both will need to be to the up position. So there's the first inverter and the second inverter switched up. So we've got the AC connections done. We've got the DC connections done. We've got the parallel connections done. All that's left to do now is turn the inverters on and then program them for a parallel configuration. And then we're done. Woo-hoo-hoo-hoo. I'm going to leave all the output breakers turned off, but we'll turn on the DC battery breakers for both inverters so that we can power them up and then do the programming for the parallel connection. So we will turn those on. And then while we're waiting for these to get to their standby state, the way the Midnite inverters decide which one is going to be the master is based on which one is going to have BMS communication to the batteries. And that's assuming you're using a shared battery bank and not a split battery bank, one for each inverter. And then if you're using a self-consumption mode or a sellback mode, that master inverter that has the BMS communication also needs to have the CTs connected to it. You only need the CTs connected to the master inverter. So out of our 2 inverters, the one on the right, my original inverter, has my CT cable here and then my battery BMS cable here. The other inverter, you can see we don't have anything plugged into either of those ports. If you're in self-consumption mode and you're selling back to the grid or backfeeding your main panel, then you want your CTs in your grid panel on your grid feed, just like you normally would for a self-consumption mode. If you're doing self-consumption with 0 export and you're not backfeeding the panel, you want to make sure that you put your CTs on the combine feed from your grid panel before you split that going to each individual inverter. Does that make sense? If you put the CTs on this side, it's only going to be reading power flow for one inverter, not both. You need to read the power flow for both inverters so that it can calculate everything properly and make sure that it's not backfeeding any power at all up to your grid panel. So our inverters are both in a standby mode. So I'm going to open up the Midnite app, and for these changes, if you haven't seen that they have a new app with remote access, reach out to your distributor because they can get an account created for you so you can have remote access enabled for your inverters. But for these changes that we're going to be doing right now, we're going to do local access, and I'll try and remember to do a video on the remote access capabilities. So inverter 125 is the one directly behind me. That's my master inverter. 024 is my slave inverter over here. So we're going to jump into the master inverter. You can see that it says grid absent, which I know that it is. We'll go down to settings, hit the gear in the top right and log in. Go to general, and then down at the bottom of general, second option from the bottom says parallel mode. So we're going to tick that, parallel mode. That's going to start the communication between the two inverters. By default, it'll say battery connect parallel because you're using a parallel battery bank. If you're using a split bank, you would change that right here. So some of the settings you're going to want to make sure that they get pushed over to the slave inverters, and they don't seem to do it automatically. It'd be nice if they did, but at this current time, it doesn't. So you want to go through and do it yourself. So the first one is going to be, let's go under power control. We're going to go to work mode. So right now my slave inverter actually thinks that it's in an off-grid state, but this inverter is self-consumption. Now if I just hit OK, it doesn't actually push the change to the inverter. So I need to change it to something else and then switch to self-consumption again, and that will push the change to this inverter. So we want to do that with our working mode. If you are using the generator or AC coupling, you have to set that up on both inverters. So you would set up a feed for the generator in both, and then you would configure the same thing for your AC coupling as well. Under battery, to make sure that both inverters are synced for the battery, I'm going to set it to lead acid, hit OK, and then come back to Midnite and hit OK, just to push that change over. And you might actually have to go through and configure your battery discharge settings on your slave inverter as well. Like I said, I wish that it would actually go through and as soon as you enable it, it would take the settings from the master and just push them to the slave, but it doesn't seem to do that right now. So if we look at inverter 1 right now, we can see that it's a solar panel with a house. BMS is at 99%, and this little icon right here signifies there's BMS communications. If we look at inverter 2, we can see that this now has the solar panel with the house, which signifies that it's in self-consumption mode. And it is still blinking, but apparently it's going to do that. But the fact that we have the BMS icon right here signifies that we have communication. And then when it rolls around, you'll see that this is at 99% stated charge as well. Both inverters currently have the A2 error message, which is regarding missing grid power. All right, so I've got both screen recordings up at the same time so you can see both screens. The one on the left is going to be our secondary inverter. The one on the right is going to be our master inverter. So we both have our A2 error. So I'm actually going to come over to our grid panel and turn on the grid supply. Now, that hasn't done anything yet because we still have our breakers closed on the inverters. And so I'm going to actually turn on the AC input breakers on both, and we should see on both of these the A2 error goes away. So I'll turn those on in 3, 2, 1. And then we can start to see that we're getting grid voltage, no output. I don't remember what the DD error stands for right now, and both of my phones are being used for screen recordings. So we're just going to turn these inverters on. Now I should be able to press the power button on either inverter, and then you're going to start to see a countdown happen in the corner, and it should be pretty close to synchronized at about 10 seconds apiece. Let me press and hold the power button to turn on the master inverter, and we should see it start to count down. The output breakers are still turned off. So press that button, you'll hear a beep. And you see on each screen it's synchronized and counting down. And then the fans kicked on both inverters. And if everything goes smoothly, we should see on the screens, everything switches. And now you can see we have output on both inverters. Again, our breakers are still turned off, but both inverters are communicating between each other. If you had any communication problems, on the top right-hand corner, you would see an error that begins with a P, and then even in your app for the logs, you would see a communication error, and it would not allow the inverters to turn on if there is a parallel communication error. So we still have the output turned off on both inverters. I've got the screen recording still going on one inverter. I believe it's the master. Yep, it's the master. So before I flip that switch and merge the two inverters outputs together, let's check voltages just to make sure, sanity check. Up at the top, 245.3, 245.9. Well, let's flip the switch, huh? In 3, 2, 1. Boom! It's always what you think is going to happen, isn't it? Merging power together kind of freaks you out. So now if I check the output down at the PDB, 246.1. I do want to look and see, the camera's going to smack me in the head. I do want to look and see what the DD error is. So let's just go into the master inverter, abnormal gen voltage. Okay, so I had configured the generator input and it's not detecting any generator input, and so that's why it's throwing the DD error. So what I'm going to do now, we still have our displays on screen. I'm going to plug my vacuum into an outlet that's dedicated to these inverters so we can see the load. And so before I turn it on, when I turn it on, you should see load being used on both of these icons down here in the bottom right-hand corner. So I'm going to turn that on in 3, 2, 1. So it looks like there was a little surge right there from the grid that the grid used to help start it. And now you can see we're pulling on both sides. And the screen's turned off. Let's turn those back on. And as we rotate through on the displays, 738, and I missed whatever it was on this side. 725, 549, there we go. So it's pretty close, 100 watts difference-ish. So that's really what it takes to get these parallel together. Now I'm actually in the middle of other tests right now, so I can't go and throw that switch to the house, but you could see with the vacuum cleaner, the load just getting split between the two inverters. Now let me give you some troubleshooting tips. So if you end up getting a P1 error, which is a paralleling ID error, I have gotten that several times, and every time it has been my fault. So if you get a P1 error, from what I've seen, usually that means that the inverters can't figure out which one is supposed to be the master because you have BMS communication plugged into both inverters. So if you unplug that from one inverter, so only one inverter has the CTs and has BMS communication, usually that error will go away. And usually what happens is one inverter starts up, the other inverter won't start up, and it just flashes that P1 error. So you'll have to unplug those cables out of the inverter that shouldn't have the communication, turn both of them off, and then turn them back on, and that should clear that error. If you get a P2 error, parallel sync, usually that means that you get that parallel cable, that 4-pin Cat6 cable that we ran between the two inverters. Usually that means that one pin isn't quite seated properly. So you're going to need to check those. And that's why I go through and I tone them out at the beginning so that I can make sure that everything is proper before I get through that startup procedure. And again, if you get the P2, shut them, put them both in standby, tone them out, find the wires that are not seated properly, reseat them, and then you should be able to turn it back on. A P3 error usually happens when your batteries are low. A P4 error, parallel grid abnormal, usually means that the grid's lost. Maybe you have an outage, maybe you have the breaker turned off. That one, to my knowledge, will not prevent you from starting up the inverter. So these inverters should be unique in that if you actually flip the breaker and turn off the output on one inverter, the other inverter will still continue to power when it's in a parallel state. From what I've been told, most errors on a single inverter should not cause both inverters to go down. The only exception to those are the specific ESS safety features for backfeeding the grid and that kind of stuff. If you get an error on one inverter for any of those, it's going to kill the entire system, but it's supposed to. It's a safety feature. But any other error that you might get on an individual inverter, the one should still keep going. In fact, I've had the breaker turned off on one before, and the other one still goes, and it just handles the load. And then when I go, whoopsies, I forgot to turn the breaker on, I turn it on and it just handles it. And actually, I've gone through unparalleled these before and forgot to turn off the breaker on the secondary inverter, turned the main inverter back on so that it was supplying power to the house, and then I noticed this weird error on the slave inverter. I'm like, well, what's going on? They're not stacked anymore, so why am I getting the error on this inverter? And it's abnormal AC output voltage. Oops. This inverter was backfeeding to the output on this breaker, and all it did was throw a warning. It didn't cook it, didn't fry it, nothing. So that was kind of sweet to see, because I thought, oh no, I ruined something because I backfed power to the output breaker. But it's like, hey, hello, over here, something's not right. And it warned me, and I turned the breaker off and the warning went away. So this is probably going on a whole lot longer than I planned on it. But I hope that it's been helpful. Just kind of walking through how you go through the process of stacking and paralleling two Midnite One inverters to get double the capacity, double the output, double the power. So with that, I'm going to let y'all go. Y'all stay safe, stay warm. I'll catch up with you later.